Hello and welcome to this video about Helidon and HashiCorp Vault integration. My name is Dmitry Alexandrov. I'm working at Oracle and I'm part of the Helidon team. With this release 2.3.0 of Helidon, there is now a brand new, fully custom-made support for HashiCorp Vault. HashiCorp Vault is an open source tool that provides a safe and secure way to store and distribute secrets, such as API keys, access tokens, and password. Software such as Vault can be critical when deploying applications that require secrets or sensitive data. The main features of HashiCorp Vault are the secret engines, which allows you to store different key-value pairs, for example, provides you PKI infrastructure, and can store your database secrets. There are also different authentication methods supported, like token-based, Kubernetes-based, or April-based methods, and of course other sys operations and configurations, enabling and disabling different engines with full management support. Currently, Vault can be accessed by the following means, like with token authentication, with April authentication mechanisms, and Kubernetes authentication mechanisms. In this release 2.3.0, Helidon provides different classes that will ease your life working with HashiCorp Vault. So the classes in this list can be directly injected by means of CDI into your code, and it can be used across your applications. When you're using Helidon SE, there are also reactive ways to support work with HashiCorp Vault. These classes can be configured, and we will see how we'll do with one of them in one of our examples. Our examples run on almost no configuration. That means we only have to specify the address of the token, since HashiCorp Vault, in our cases, will be running just as a Docker image. Okay, let us now jump into some code. As always, we will start with some dependencies. Of course, for Helidon MP, we need the Vault CDI dependency, as well as several other dependencies. They may sound like quite a lot to you, but it's just because we're keeping it very modularized. Okay, in this example, we will use the most traditional KV2 pair storage, and this is considered like a default key-value storage now in HashiCorp, and here we will create some examples with it. So as you see, we have a KV2 secret support class, which can be directly injected, as mentioned before. So Helidon will just inject the class, configure it, and do everything for you. And now we will create 3 methods to work with HashiCorp Vault KV2 secrets. So the first one will be the create secret. That means that we will just use this method when we want to create a secret. As you see, it's a post method, so it will be called like create secret. The first parameter will be the path parameter. Actually, in our case, we store secrets on certain paths. So that means that the first thing is like a key is the path, and then the string secret is actually something that we deliver as a data with post request. So as you see, we now have this secrets class, which has a method create, and this method creates returns a KV2 object response. So as you see, we just to the certain path create a map of secrets, because we have to support versions actually here. So we will have the response object, which will tell us if everything was okay. So in our case, we will just return the response, like the normal JAX-RS response right now, and write down that we just created a secret on certain path. Yes, in our case it will be just path, because once again we are associating paths with secrets. So it's a path object, and the key is actually secret for this map. And under this path, we have the original response. This is something that gives the HashiCorp back to us. So we're saving it, and we're also delivering the status. So we not only can put on the data, but we also can monitor the statuses from HashiCorp Vault. Okay, it's very straightforward. So now let's do the delete method. So it's going to be on path. Once again, the same secrets. And once again, that will be on path as parameter. And once again, quite straightforward. Just do the public response. Here, we will just delete secret. And once again, we will read the path parameter, something that we want to delete. Yep. So we just string path. Okay. Yes, so there's a small stupid mistake here. Yes, we just fixed it. Lovely. So once again, we will use our secrets object, which will return a delete KV response object to monitor the result. And there is a delete all method, which just takes path as a parameter. And yes, now it's correct. And we just do it like path. And of course, as a OK, we will return. So it's going to be like a normal return of a JAX-Express. Yes, we will say that we have just deleted the secret on the following path. So we'll just say path. And we will also, since we are able to return the original response, we will just return the original response and its status. You see, it's very straightforward. Yes, and it gives you good ability and good observability, which is wonderful. And of course, last, but something that we really want is to read the secrets, actually. So once again, we finally got to the get method, which is once again on the same path. Yes, yep, absolutely great. And of course, once again, I'll get a public method with one response, which is called getSecret. And we will just get the path parameter as path. And once again, string. And we are now able to read it. Yes, under this path, we will read these secrets. So once again, we're using secrets and then get object. We will create a local variable with it. Like since the secret can exist or not, it's wrapped with optional. And that means that we are able to see if the result of the secret is available, which is get it and return it to our customers or somebody who calls the method. So once again, we're creating a response like of type OK, so everything is OK. When we put the entity of yes, say once again we can even do versioning here. So we, as you know, we keep it everything with versions in HashiCorp Vault. That means that we can read the metadata from the returned object, like we are returning a secret of certain version, and that means that all the metadata is available to us via this integration with Helidon. And we are almost done, so we just now have to build the object, and we are there, almost there. No, actually not, because just when there's no secret present under the path we've supplied, we will just return like nothing, like not found. Yeah, so it's 404. Yep. And we just build a response, and we are done. Look, so with just a few lines of code, we are there. Now let us just build it. So Maven clean package. It should be really short. So here we got our vault, which is running in a Docker container. We see that there are no secrets here. Nice. Okay, let us do java -jar. You see how fast Helidon starts with our support of Vault. Okay, let us now create a post method with secret. and see if the secret is there. It just logged out us, no problem. We will go to the demo and see, yes, the secret is here. So cool. Let us now, yes, read it from the curl. You see it's there. Yay. Cool. And the final thing we should do is actually delete everything. So we just make a curl delete of this demo. Oh no, wrong. Yes, demo. And we are like done. Oh, it threw us all away. Yes, you see 404, nothing is done. It just throws us away constantly. Yep, I will use different links next time. Yes, so you see, no secrets here. So, great. Okay, let's now switch to Helidon. So we got Helidon SE. So we got almost the same dependencies, so only without the CDI actually. And what is cool of them is they are reactive. So let us jump into the main method of our Helidon SE class and create our Vault support object, which we call token Vault. So it also has its builder. So we are reading the configuration. Actually, as you see, there's almost no configuration. That means there's only just the server location actually, and the way to authenticate to the server itself. So that means we only read the config. So yes, so there's something that we want to do, like update client, to make like some timeouts, because now we're actually consuming the data from here, so not to wait too much. If something is wrong, that means that here we just say, so the connection timeout for us to query different services like 5 seconds. Okay. Yes, so read time and write down. Yeah, connection time. Yeah, just to make it absolutely transparent and to see to save faults. Okay, so as we get the token Vault support, so we will also include the system object. The system object is something to control different HashiCorp Vault items, to turn on or turn off different authentication objects. So there is a reactive way of doing this. That means that we have sysRx for that. And the next thing we should do is actually include the routing. That means that we just have to create a routing object, which is new. Yes, we just have the builder of it. We register an endpoint here, which is like KV2. We will do the same stuff. And for that, we have this KV2 service, which returns this sys object for controlling the HashiCorp Vault himself. And that token Vault actually access it. Okay. Yes, and we will use like KV2 secrets, which we will use in our service. So we will use the KV2 engine. Yes. Actually, there is something wrong. Let us fix this. Yes, KV2, KV1. Oh, no. Yes. So that's my mistake. Oh, yes, of course, KV1 is not to be mixed with KV2. So we have a KV2 service, which we are now going to create. So as you know, Helidon SE just is a pure Java. That means we have to create a class which implements the service method. And in our case, this method just has to be not method, but this class has to have two fields, like system object for controlling HashiCorp Vault itself. So it says Rx, so Rx is for reactive. And of course, the next thing is the KV2 secrets Rx object. So it's a reactive object to support secrets in Helidon 2, in Helidon SE. Yes, we should just create a constructor for them. Nothing special. And yes, you see still red. That means we have to implement the method update. Yes, the method update to set up the routing rules. And once again, to set up the routing rules, we just assign them a path and the handler object. So we will create 3 methods here. Yes, first one is the create secret method. Yes, it's still not there. That's why it's in red. Then we're going to get the method for like yep, secrets path. Yep, just get the methods. Yep, secrets, and well, it has to specify the handler method, and of course the delete. We'll do it a little bit later. So, and the delete, of course. So under certain path, which in our case will be like secrets, and then we have the path parameter. Yep, correct, almost there. And then we just specify the handler methods here. So once again, in our case, it will be like because look, so we don't have them implemented. So let's find a good name for that. It will be like yes, get the easiest name. It's a get secret name. Then the last thing about delete will be just delete secret. Nice. Okay, they still turn into red just because we have to implement them. So let's do it. Let us first start with the create secret method. Yes, once again, it's a request response. These are the standard function that have to be implemented in order to handle the request correctly. And let us see what we do there inside. So as you see, we have our secrets engine that we passed from the main method. So it has a create method. Under certain path, we create a map of just secrets. As you know, we have to submit a map of object there just to keep the versioning and all that stuff. And we say like key is the secret value. And whenever we created it, since it's a reactive way of doing things, we just have to, because it returns a completable future, we then say whenever it's done, that accept our result, and we just send the result that everything is okay, like created secret on a path. Yes, so there's just a lambda method. So we just created it in a path called first and secret. And of course, since exception may happen, so we have the exceptionally method, which is like response send, and we are almost there. Nice. So the create secret is okay. Okay, now the next thing we should do is actually let us get the secret. So once again, it's a server request response method. That means we have request and response there. As parameters, this is required to be this handlers to work correctly. And once again, we are reading now a path parameter. So as you know, in Helidon HashiCorp, it's just a part of the request object, just path and param. Yes, here the thing cannot be just injected, so no magic, we have to do it ourselves. And that's why we say, once again, so secrets object has a get method when it gets the path, and it returns a completable future. Completable future, and it means that we are asynchronous, which means that whenever the result is done, we have we're checking actually if the secret is present, because once again, maybe we have spelled wrongly the path, or maybe there is no secret under this path, that means that we just do have to understand whether there is secret there or not. So if it is present, we just get the secret. So there's for a special KV2 secret object for him. So there is object for KV1 as well. There's object for different other ways of keeping the key value pair. So in Helidon, for everything, there is an object which corresponds. Okay, and the next thing, of course, is just to send the result, which is the version. And of course, we can read the metadata. So in this metadata gives us ability to read the version of the current secret. And of course, we can read the value and send it to our customers for this method. And of course, if the secret is not present, yes, whenever we understand it in a reactive way, so we just send that the status is like we just send it 404, I guess. Yes, 404 will be the best option here. That means we just send this this status like we didn't found it. Sorry. And once again, if something runs exceptionally, we have to carry it gracefully. I guess this is for the get secret. And we have one last method to implement is the method of delete the secret. So the delete should be like a little bit shorter than the previous methods. Yeah, actually, because yes, we just have to read the parameter. So once again, we read the path parameter. Path parameter just gives us the designation of this object that we have to return. Yes. So we read the path. Then we will just, of course, use our secrets object and use the delete all method. So it will be just delete everything regarding on this path. So we return secrets like all on this path. And as always, it's asynchronous because there's Rx in the end. Yes, so and we will just send the notification to the user, just a lambda with it. That we have just deleted everything on path, everything that lies on this path. And we'll just send it to it. Yes, the right word is not sent, but send. Yes, great. And we are almost there, I guess. So you see a few lines of code, and we have a completely working solution with Helidon SE and HashiCorp Vault. Let us now clean package everything. It's very much fast building. We're starting it. So this example is set on our examples that we have, and as you see, we click here, we just get the secret value. Wonderful. So whenever I get the secrets, we can read them, and of course we have to curl to delete them because browser does not send delete. And yes, we are now able to safely delete everything. So this is it. This is how it's done, and I hope that you will enjoy even more examples with HashiCorp Vault, because this was only demonstration of KV2 actually. But if you go to our official website, you will find a lot of more examples in our GitHub repository. So as you see, it's working. Nice. I hope that you found this video useful. If you have more questions, please refer to our documentation for Helidon MP or Helidon SE on these links. If you want to play more with the examples, just go to our official GitHub repo and find the examples on integration Vault. Thank you very much. Bye bye.